In this video, we'll write a program that will check if the given number by a user is a prime number or not. But before we start with that, let's remind ourselves a prime number is any number that is divisible by 1 and itself, right? But if it is divisible by any other number, then it is not a prime number. So what are some examples of a prime number? Some of them are 2, 3, 5, 7, 9 is not a prime number because it is divisible by 3 and 11. So if we take any number from here, let's say 7, we can see if we divide a 7 by 1, we get a 7. If we divide by 7 by 7, we get a 1. And these are the only two numbers that it is divisible by 1, right? So then it is a prime number. If you try to divide any number less than a 7, then it is not a prime number. So this is what we have to do in this program. So how do we go about doing this? So in order to get a input from a user, we'll use something called a scanner, and using that scanner, we'll say scanner is equals to scan is equals to new scanner. We'll instantiate that and we'll provide it a parameter system.in. So in order to use this scanner, we'll have to import a library from a scanner library, and it belongs to java.util.scanner. Then only you'll be able to use this. If I remove this, you can see it will start complaining because it does not know what the scanner is. Therefore, we'll have to import this and see for it to work, right? Now that we have a scanner, let's prompt a user to enter a value. So we'll say system out.print, not ln, but rather we need only a print, and we'll say enter a number. So once we prompt the user, we need to make sure we read whatever the user has provided. So let's declare a variable which takes in a number. So in order to read a value, the scanner library has a method called scan.nextInt. So what this does is it literally reads the value from the keyboard that the user has provided. So let's see if we have read the value properly or not. So what we'll do is just print the value of a num, right? Let's go run this program. And once we run this program, we can see we enter 5. We can see we get a 5 back. So we know that it reads the value and then it outputs the value to us. So now, what do we do? So in order to check if a number is a prime or not, let's use a Boolean variable and we'll name it is prime. And by default, the number is already a prime. And when we mentioned that the prime numbers, we realized that a prime number starts from a 2, nothing less than a 2. So we already know that if there is anything less than a 2, it is already not a prime number. So instead of wasting our time and looping through all the numbers, by default, let's say if the number that the user has provided, if that is less than or equals to 1, all right, that number is not a prime number. So we'll make is prime equals to false. So we know that now the prime number is not a prime number if it is 1 or less than 1. But what if it is more than 1? We know what to do, right? If it's more than 1, we go and loop through it. I'll tell you in a sec why I'll be looping through. So we'll say int I is equals to, now we begin with 2 because we don't care of any number less than a 2. And since I is less than the number that the user has provided, and we increment through the value. So why are we looping through? We are looping through every number because we need to go and divide every number by that number that the user has provided, right? So what I'm trying to say is, let's say a user provided a 5. So what we'll do is we'll go and say 5 divided by 2. Then we'll move on and we'll say 5 divided by 3. Then we'll move on. We'll say 5 divided by 4. You get what I'm trying to do? So we'll have to loop through every number and divide so that we can check whether if the number is divisible by 1 in itself or is divisible by more than one number. That's why we are looping through the entire array, right? So after we loop through it, we need to go and divide. But rather than divide, we'll call something called a modular. So what a modular does is we'll say if num modulus I is equals 0. So what this will do is, let's say it takes a number, right? It takes a number, again a 5, right? What it will do is 5 modulus 2. Let's say it's on the first one, and we know that 5 divided by 2 gives us an answer of something like 2.5, right? So modulus checks the decimal value. Anything after the comma, that's what it checks. If it is equals to 0, right? Or not. So here we are checking if it is equal to 0. So if it is equal to 0, we need to do something. We can see in this case 5 modulus 2 is not equal to 0. Therefore, we know that that is not a prime number, right? So here we'll just say is prime. If modulus equals 0, then is prime is equals to false, right? So you get what I'm trying to do. So if 5 modulus 2 gives us 2.5, we can see after the comma, we have a value as a 5, not equal to 0. It means this is not a prime number yet, right? Then we move on to 5 divide by 3 or modulus 3. This behaves similar to division, but it rather looks at a value after the comma. Once we do that, now we can get some answer as 1 point something, but there is something. I'm not putting a right answer, so don't judge me for that. So it can be something like that. We know that the answer is still false because there is something after the comma and which is not a 0. Therefore, we know that is prime is equals to still false. So the moment it comes inside, we know is prime is false. And the moment you do that, suddenly break out of it, right? If is equals to false, just quickly break out of it, right? And then what do we do? In this case, we have finished checking whether if a number is prime or not. Now we need to tell whether if it's false, what to do, and if it's true, what do we do? So we need to write a condition, right? So we'll tell it if is prime. So when we have something like is prime without saying equals true, by default it's true. So we don't need to write that. So we're saying if is prime, then tell the user that, let's put it on a new line rather than on the same line, we'll tell the user that it is a prime number. What is a prime number? The number that you have provided to us is a prime number. But what if is not true? If it's not true, then if you're a programmer, learn to copy paste. That makes your life way too easy. Is not a prime number. And then finally, we go and close the scanner. Scan.close. We always, whenever you use a scanner, always remember to close it, right? So here, let's go through it again one more time. Here we have declared a scanner, all right? And we have passed in system.in. We ask a user enter a number, and then using scan.nextIn, we read in whatever the number is provided. Then we have a variable called is prime. By default, the number is true, right? We know that a prime number starts from a 2. We don't have to worry about any number less than 1, right? So if the number is 1 or less than 1, then we don't have to even worry about looping through. We just tell them, oops, that's not a prime number. But what if it's greater than 1, right? Then we need to go into this. We loop through the every number. Then what we do is whatever the number the user has provided, we divide by the increment on which we are, and we see if the decimal value is equals 0, then that number is a prime number. If not, then it is a false. So let's go and run this. If we run this and let's provide a number 5, we know that a 5 is a prime number. And we enter this, we can see we get an answer as 5 is a prime number. But let's enter 9, right? Let's go and rerun this program and let's enter a 9. We can see 9 is not a prime number. So this thing works. But there is a problem with this, right? So if I run this, right, let me remove the debugger and let's run this. And I put a really big number, right? Let me warn you from now. My machine, it's very powerful in terms of CPU and GPU. So this will give the output really, really quick. So don't judge upon how fast this gives me as an output, right? This can be a really slow process. Why it can be a really slow process? Just imagine how many times you'll have to loop through to get to this number, because you are going through the entire number and seeing whether if that number is a prime or not. Like I said, my machine is really powerful. That's why it was quick. But if you have a slow machine, this can take ages to load, right? So how do we go about solving that? And this is where you can win your interviewer, right? What you can do is, in maths, in order for a number to be a prime, and in order to lessen the time, what you can do is you can, instead of saying less than number, you can say less than or equals to, you can say math, right, dot the square root of a num. So what you have done is you have taken a number, right? Let's say our number is 16, right? A square root of 16, that's a 4. So according to maths, it says that if number 4, you'll have to loop until 4. If a 16, right, you loop until 4 and you find that there is a number that is divisible, right, then that number will be a prime number. That's what maths says. So for instance, let's use 16 in this term. We know 16 is not a prime number. And if you put a 16 here, we can say 16 is not a prime number. So what math says is, if I use the square root of that number and I go and divide that number by those ones, I will definitely find out whether if that number is a prime number or not. And I trust maths to be fair, right? I do trust that, and it gives the accurate answer. Now what this does is it reduces your number of iteration that you do on line 16, and it makes it a quick to do, right? So I know when you use a short number, then what it will do a less iteration. But if you have a big number, right, it will be really quick to solve that answer. And this is where the main, what you call, attention lies of this problem. They want to see if you use math dot square root or not, and go and explain them that why you use a math dot square root is because you can see when using a math square root number, you can already find a prime number or not. There will be no chances that if you use a square root, then you'll give a wrong result. You want, if a number is divisible, you'll find out if that number is a prime or not. But if it's not, then it will not be. So always use a math dot square root to solve your problem. So this was the perfect answer to know what your prime number is and what your prime number is not. So don't forget to use math dot square root. That is the entire solution of this program. If you like this video, please like and subscribe. And let me know in the comment box below what kind of videos you want me to solve. Also, until next time, stay safe.